Alright, this is one of the tricky questions that I found in new Qmaths 12B chapter 3 exercise. Oh, sorry, as I believe it's 3.4, not 3.5. Question 6G. Alright, so is log ax equal to 2 plus log bracket 1 plus root x. Now the biggest problem I see when I first look at this thing is this root x. Alright, we have to try to get rid of it. We have to try to get rid of the root x. This one. Alright, that's the big problem. Alright, so normally what I would do when I see 2 log, and when this log is not given a specific base, I will usually just pretend it will be log 10. Alright, so what I would do is I'll put the logs together. So log ax, move this bit to that side, minus log 1 plus root x equal to 2. Alright, now with our log laws, when you got the log with the same base and you subtract them, when you subtract them, it's just equal to whatever inside and divide each other. Like that. Alright, so now assuming this is log 10, right? Assuming this is a log 10 here, I can move this to the right hand side by doing this, 10 to the power of 2, right? Okay, and then, well, I know what 10 to the power of 2 is. 10 to the power of 2 is just 100. Okay, so far so good. Now, right here, I mean, people might try to simplify whatever. It doesn't work because if this root x is troublesome, and we're trying to get rid of the root x. Alright, and we know the only way to get rid of the root x is square root it, right? Well, not the only way, but no, the easiest way is to square root it. But you can't square root this right now. Alright, that's a big no-no. No. Alright? Right, the reason why you can't do this is, well, you can, when you do that, you can square this. And that give you 64x squared. That's good, but when you square this, because because the whole thing square, right? So this, when you square this, remember our binomial, expansion, which is, perfect square, is a squared plus 2ab plus b squared. So a squared is 1, 1 squared is 1, plus 2ab is 2 times 1 times root x. We got a root x here. Right, b squared is just x. Right, we still got a root x here. It doesn't really help us at all. So what I'm trying to, and I fall into that trap at the beginning as well, and I thought, this doesn't work. But I realized all we have to do is single out the root x first. Alright, let's single out the root x first. So we're not going to do that. We're not going to do this. So let's single out the root x. Alright, by singling out the root x, what can we do? We can move this to that side and this to this side. So it becomes ax over 100 equal to 1 plus root x. Right? And then we go ax over 100 minus 1, yeah, moving the 1 to the left hand side, equal to root x. Now we've got the root x by itself. Alright, now we can square both sides. Equal to root x squared. Now this will get rid of the root, so this gives us x. Right, and now when you square when you square this whole thing on the left hand side, we go through the binomial expansion, which is a squared minus 2. But this is a minus in the between, right? So it will be minus 2ab plus b squared. All right. So it will become ax over 100 square minus 2 times 1 times 2a over 100 times 1, right, plus well, b squared is just -1 squared. Alright, now we can do this one. That's easy. So 64x squared over 10,000. Because, you know, when this way, the square encloses the whole thing, so you have to square the bottom as well. Alright, minus, now 2 times 8x over 100 is just 16x over 100 times 1, and that doesn't really change, plus a -1 is just, -1 squared is just 1, so plus 1 equal to x. Right, and now this looks like this look pretty much like a quadratic to me. Alright, so 64 over 10,000 is just 64 divided by 10,000, and we get 0.0064 x squared minus 16 divided by 100. 16 divided by 100 is just 0.16, right? X plus 1 equal x. Alright, so all we have to do last, we just move the x to the left hand side as well, so it becomes 0.064 x squared minus 0.16x minus x. Well, plus 1 equal to 0. Now this minus x is same as this minus 1x. Right? Just to make it clear, it's minus 1x. Alright, so 0.0064 x squared minus, alright, so negative 0.16 minus 1. That is just negative 1.16 x. Alright, plus this 1 equal to 0. And now we can use GC, alright, which is a graphic calculator solver, to solve this. Right? And I believe the answer, the result we get, there should be 2 answers. The 2 answers we got is, therefore, the 2 answers is x equal to 180.38, or approximately, I'll just round it up, or x is equal, or approximately equal to 0.866. Alright, so to check if both of the answer is correct, we sub them back in. Sub the answers back back into log ax equal to 2 plus log bracket 1 plus root x. Alright, and I already did that, and I think this particular result doesn't work. Oh, don't work. And this one works. So the only answer the only valid answer should be 180.38 approximately. Alright, and that should be the same on the textbook as well. So yeah, so one of the tricky stuff here is, if you see the root x, if you see a root x in your equation, right at the beginning, if you see the root x here, alright, you have to try to single it out, so making on one side and then the other is blah 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 blah, and then square both sides. So that makes it better. That actually get rid of the square root. And at the end, once you got your answers, right, remember, do not forget, this is not a solving quadratic problem. So this is a logarithmic question. So you have to solve for the x. So not every time both answer work. So make sure you check the answer by subbing it back in to the function. Make sure you do that. Alright, so that's it. Hopefully that helps.